Hey everyone, welcome back. Ready for another deep dive?
Definitely. Always ready to explore new cosmic frontiers.
Well, today we're headed to the outer reaches of our solar system, to the icy world of Pluto and its largest moon, Charon.
Pluto and Charon, they're kind of like the odd couple of the solar system, right?
You could say that. They're this fascinating binary system, and we've got this new scientific article that's shaking things up in terms of how they formed.
Oh, I'm intrigued. What's the article suggesting?
Well, you know how we usually think of planetary formation as this big, violent process, lots of crashing and smashing.
Right, the classic giant impact hypothesis.
Exactly. But for Pluto and Charon, it might have been a little more, well, romantic.
Romantic, now you've really got my attention.
Okay, so imagine the outer solar system billions of years ago. It's this vast, cold, dark expanse.
And way out there, we have Pluto and, well, whatever Charon was before it was a moon.
Right, probably just a bunch of icy debris floating around. Now, the old theory, the giant impact hypothesis, said that Charon formed kind of like our own moon.
A massive object slams into Pluto, a ton of material gets thrown out, and boom, eventually it all comes together to form Charon.
Exactly. But Pluto and Charon are different. They're smaller, they're much colder, and they're mostly made of rock and ice.
So the whole molten debris flying everywhere scenario doesn't quite fit, does it?
That's what these researchers from the University of Arizona are saying. This new article proposes a totally different model for how Charon came to be. They call it kiss and capture.
Kiss and capture. Okay, that's definitely not what I was expecting. So what's the idea here?
Instead of this violent impact, picture a gentler interaction. Pluto and this proto-Charon, they kind of bump into each other.
But instead of a full-on smash, they stick together for a bit.
Exactly, like a cosmic snowman just spinning around out there in the darkness. And then, slowly, they start to pull apart.
Wow, so instead of a fiery explosion, it's more like a slow cosmic dance.
Yeah. And eventually, that dance settles them into the orbit we see today.
Fascinating. But I'm guessing there's more to this kiss and capture idea than just a cool name.
Oh, definitely. This model isn't just about rewriting the story of how Charon formed. It has some pretty big implications for how we understand the formation of, well, everything in the solar system.
Okay, I'm all ears. What are some of the key takeaways here?
Well, for starters, kiss and capture challenges those traditional models of planetary formation. The ones that assume these big chaotic collisions are the main driver.
It's a totally different way of looking at things. Almost like saying, hey, maybe the universe isn't always about those big dramatic events. Sometimes the most important things happen slowly and gently.
Exactly. And what's really interesting is that this kiss and capture model doesn't just explain how Charon formed. It also explains why it's in the orbit it's in today.
Ah, so it's a two-for-one solution. Elegant and efficient. I like it.
Right. It's a much neater explanation than what we had before. And there's more. The article also mentions something about Pluto and Charon's internal structure being largely preserved because of this gentler formation process.
Interesting. So if they didn't experience that massive melting impact, what does that tell us about their insides?
Well, it means that their original composition, all those building blocks from the early solar system, are likely still there. It's like having a time capsule from billions of years ago just waiting to be opened.
Wow. A time capsule from the birth of the solar system. That's incredible. But hold on, we're talking about Pluto here. It's incredibly cold and far away from the sun. How could anything possibly stay preserved for that long in such a harsh environment?
That's a great question, and that's actually where things get even more interesting. It all ties back to this kiss and capture model. Even though the initial interaction was relatively gentle, it still generated a lot of heat. And that heat, combined with some other factors, may have led to some pretty surprising activity beneath Pluto's surface.
Like what? Volcanoes? Ice geysers?
Well, maybe not that dramatic, but there are hints that something pretty amazing might be lurking beneath all that ice. We're talking about the possibility of internal heat, maybe even oceans.
Oceans on Pluto. Now that's a thought. But how could there be enough heat to melt ice that far out in the solar system? It's practically in interstellar space.
Well, that's what makes this kiss and capture model so intriguing. It not only explains Charon's formation, but also hints at these incredible processes that might be happening deep inside Pluto. And that's where we'll pick things up in part 2 of our deep dive.
Welcome back, everyone. It's amazing to think that this whole kiss and capture model might be the key to unlocking so many mysteries about Pluto.
It really is. We left off talking about the possibility of Pluto having internal heat, maybe even oceans. It's kind of hard to wrap your head around, right?
Yeah, I mean, when you think about Pluto, you picture this cold, icy, distant world. Not exactly the kind of place you'd expect to find liquid water.
Right. But that's what makes this research so exciting. It challenges our assumptions and opens up all these new possibilities.
So how do we go from a gentle kiss to a world with enough heat to melt ice?
Well, remember how we talked about Pluto and Charon being in a tight embrace right after their initial interaction?
Like a cosmic dance spinning around each other.
Yeah. Well, all that spinning created some pretty intense tidal forces. We're talking about massive bulges stretching and squeezing both Pluto and Charon as they rotated.
Ah, I see where you're going with this. All of that stretching and squeezing generates friction.
Exactly. And friction generates heat, even more heat than the initial kiss itself.
Interesting. So even though the impact wasn't as violent as we once thought, those tidal forces could have really cranked up the heat inside Pluto.
That's the idea. And all that heat, combined with the heat from radioactive decay within Pluto's core, could have been enough to melt a layer of water beneath the surface.
So we're not just talking about a little bit of melting here and there. We're talking about a potentially vast ocean, hidden beneath miles of ice.
Exactly. And this ocean wouldn't have just existed for a short time and then frozen over. It could have persisted for billions of years, all thanks to those tidal forces and the insulating properties of that thick ice shell.
It's like Pluto has this secret, hidden world beneath its surface, a world that's completely different from the cold, barren landscape we see in pictures.
Absolutely. But how can we be sure this ocean actually exists? I mean, we can't just drill a hole through miles of ice to check, right?
Well, not yet, anyway. But scientists are pretty resourceful. They've developed some clever techniques to study Pluto's interior without actually having to dig down there.
Like what?
Well, for one, they can use radar. By bouncing radar signals off Pluto's surface and analyzing how those signals reflect back, they can get a sense of what's going on beneath the ice.
So it's kind of like an ultrasound, but for a planet.
Yeah, you could think of it that way. And they can also study Pluto's gravity field. Variations in the gravity field can provide clues about the distribution of mass within the planet, which can help us understand whether there's a liquid layer hidden beneath the surface.
So by piecing together all these different clues, from radar data to gravity measurements, scientists are starting to build a pretty compelling case for a subsurface ocean on Pluto.
Exactly. And it's not just about finding the ocean itself. It's about understanding what that ocean might be like. Is it salty? What's its temperature? Are there hydrothermal vents on the ocean floor?
So many questions. And I'm guessing the answers could have some pretty big implications for the possibility of life on Pluto.
Absolutely. We've found life in some pretty extreme environments here on Earth, places we once thought were completely uninhabitable. So who's to say that life couldn't exist in Pluto's ocean, especially if it's been around for billions of years?
It's mind-blowing to think about. And speaking of mind-blowing, we also touched on how this kiss and capture model might be relevant to other binary systems throughout the universe.
Oh, yeah, that's a whole other layer to this story. If this gentler formation process is more common than we thought, then the possibilities for finding other hidden ocean worlds, maybe even worlds that could support life, just went way up.
It's like we've been focusing on the big, flashy collisions all this time. And now we're realizing that some of the most interesting things in the universe might be happening quietly and subtly.
Exactly. And that's what makes science so cool, right? You never know what new discovery is going to come along and completely change our understanding of the universe.
Absolutely. But before we get too carried away with all the possibilities, we should probably bring things back down to Earth. Or, well, at least to Pluto. We still haven't answered the big question. Is there life in that hidden ocean?
That's a great point. We've laid the groundwork, explored the evidence for the ocean itself, but now we need to delve into the tantalizing question of whether we're alone in the solar system or if there might be something swimming around in the depths of Pluto. And that's where we'll pick things up in part 3 of our deep dive.
Okay, so we've established that Pluto might have this incredible hidden ocean. But the big question is, could anything actually live there?
Right. We can't just assume that because there's water, there's life. Life needs more than just H2O to survive, especially in an environment as extreme as Pluto's subsurface ocean.
So what else do we need to consider? What are the ingredients for life as we know it to exist?
Well, aside from water, you need a source of energy and the right chemical building blocks, things like carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur.
Okay, so kind of like a cosmic recipe for life.
Exactly. And scientists believe that Pluto's ocean might actually have all of these ingredients.
Wait, really? Even that far out in the solar system?
Yep. Remember we talked about how the kiss and capture model suggests that Pluto and Charon didn't experience a super violent melting impact?
Yeah, their internal structures are thought to be relatively intact.
Right. So a lot of the material that Pluto formed from, material that's rich in those essential elements for life, could still be present in that ocean.
Wow, so the building blocks are there, but what about energy? There's no sunlight reaching Pluto's subsurface ocean.
That's true, but sunlight isn't the only source of energy that life can use. Remember those tidal forces that we talked about? The ones that might have generated enough heat to melt the ice in the first place?
Yeah, those are pretty intense.
Well, those same forces could also create something called hydrothermal vents on the ocean floor.
Hydrothermal vents, what are those?
They're kind of like underwater geysers or hot springs. They release heat and chemicals from Pluto's interior into the ocean.
And those chemicals could provide energy for life.
Exactly. Here on Earth, we found entire ecosystems thriving around hydrothermal vents deep in the ocean where there's absolutely no sunlight.
So you're saying there could be these alien life forms, completely adapted to darkness, just hanging out around hydrothermal vents on Pluto's ocean floor.
It's a real possibility, and it's not as crazy as it sounds. We know that life is incredibly resilient and can adapt to some pretty extreme environments.
Okay, I'm starting to see the potential here. But how would we ever know for sure? I mean, we can't exactly send a submarine down there, can we?
Not with our current technology, no. But scientists are working on some pretty ambitious ideas.
Like what?
Well, one idea is to develop a probe that could melt its way through the ice and then explore the ocean directly.
Wow, Pluto ice melting probe. That would be amazing.
It would, but it's a huge technological challenge. I mean, we're talking about miles of ice.
Yeah, it makes landing a rover on Mars seem like a walk in the park.
Exactly. But who knows what the future holds? Maybe one day we'll be able to send a mission to Pluto that can directly sample that ocean and search for signs of life.
Well, I, for one, am definitely rooting for the Pluto ice probe. But even if we never get to send a mission there, just the possibility that life could exist on Pluto is incredibly exciting.
I agree. It really expands our perspective on what's possible in the universe.
It also makes you wonder if kiss and capture is responsible for Pluto's potentially life-harboring ocean, what other wonders might be hidden out there in the vastness of space?
That's the beauty of science. Every new discovery opens up a whole new set of questions and possibilities.
Exactly. So to all our listeners out there, keep that sense of wonder alive. Keep exploring, keep questioning, and never stop looking up at the stars. You never know what incredible secrets the universe might reveal next.